Hey, this is Mr. Ward, and welcome to Chapter 3, Section 2, Number 10. In response to some confusions that were expressed by some folks, I thought I'd give a little walkthrough of this. So, first of all, we're given some information about this shape here that might be a parallelogram, but we can't assume that. And then we're given some information about the measurements of the angles. We're given a specific value for one, not the measurements of the angles, given a specific value for one of the sides of this thing. Okay. And then we're supposed to figure out the measure of angle GOH, this is GOH, and the measure of GHO, and the measure of segment GH from all of this stuff. So it will work. So let's start organizing the information we have. So we know that this side is congruent to this side. We know that information. We know that, okay, let's actually finish labeling things. We also know that GJ is congruent to OK. And that was me trying not to sneeze on the video. Okay. We know that angle G is congruent to angle K. So I'll pick a different color for that. Angle G. There's nothing ambiguous about what angle G and angle K are. So we know those are congruent to each other. Now, we know that H is the midpoint of GJ. So if H is the midpoint of GJ, then we have two congruent parts. This is congruent to this. And it says M is the midpoint of OK. And by division, since we would be dividing two congruent parts, OM and MK are also congruent to GH and HJ. So all of those are congruent to each other. And I'm signifying all this with my colors. Now we finally have some information here that OK, and I'll use this light blue for that. OK is a measure of 27 units. It doesn't say what kind of units, so I'll assume it's Badgers. We know the measure. Okay, so let's start thinking about what we know. Well, we know this side is congruent to this side. We know this angle is congruent to this side angle, and we know this side is congruent to this side. So that will also let us know that triangle GHO and triangle KMJ are congruent to each other. And if by side angle side. So side angle side will prove those triangles are congruent. And if those triangles are congruent, then this is the Kappa-Kadaka chapter. By corresponding parts of congruent triangles, those corresponding parts of the congruent triangles are congruent. And there's other things that will have to be congruent too. This angle will have to be congruent to this angle because they correspond to each other and they're parts of congruent triangles. And this angle will have to be congruent to this angle. And so now we have a whole bunch of information that we didn't realize we had before. So let's look at this measure of GOH is x plus 24. Now, to figure out what that's going to be, it would be really useful to be able to figure out some other angle that's congruent to GOH and see if it's in terms of x as well. So this is GOH. That's this orange color-coded angle. Let's look for what the other one is. The other one is MJK. That's congruent to it. And MJK is this expression here, 4x plus 105. This is x plus 24. So we could actually make those two equations equal to each other since those measures are congruent. And then we can just solve for x. So x plus 24 And that's going to equal 4x minus 105 because those angles are congruent. So their measures are congruent. 4x minus 105. And that will allow you to solve that. Okay. And that'll give you those two angle measures if you want them. And we just want GOH, but MJK will be the same as GOH. Now let's look at GHO. Angle GHO is this blue one, and the other blue one is angle JMK, and those are conveniently using the same variable. Okay, so y, they're both using y, so we can actually set a second equation up with those. 2y minus 7, because those two angles are congruent, their measures are congruent, so we can just say 2y minus 7 equals 3y minus 23. And that will lead you to a solution to the measure of angle M. You can find out what y is, and then once you know what y is, you can plug it back into either one of these and figure out what the angle is. Just like up here, you can figure out what x is, and then you could plug x back into x plus 24, and you'll know what the measure of angle GOH is. Finally, we're supposed to figure out what GH is. Well, we know OK is 27, so then we also know that GJ is 27, Badgers probably, and GH is half of GJ because H is the midpoint. So you just need to find out what half of 27 is. Now, I'm not going to give away all the answers, but I think I've given you what you need to solve this at this point. Just to recap, go through all this information, and it'll get you eventually, the midpoints are key here. The midpoints will let you know that GH and MK are congruent. Okay, that lets you know that. And then you've been given GO and JK. You've been given angle G and angle K. From there, you'll end up with side angle side for both of these triangles on the ends. And that'll lead you to what angles are congruent and what sides are all congruent using corresponding parts of congruent triangles. And then you've been given enough information to do some simple algebraic equation solving. There's no systems of equations to deal with, really, other than maybe you could treat this as substitution. So you can set these two expressions as equal to solve for x, and then plug x back into this, whatever x is. Set these two expressions to be equal, since the angles are equal, and then you just have to get half of 27 to find out what GH is. I'm gonna stop now. I hope that was helpful.